Welcome back to the channel. My name is Marcus Reed, and if you are here right now, wherever you are in the world, whatever time it is beside you, I want you to take a moment before we begin and simply notice where your body is. Notice the surface beneath you. Notice the weight of your own limbs. Notice the temperature of the air against your skin. You are here. You are safe. You have nowhere to be and nothing to do for the next hour except listen. Tonight, we are going somewhere very specific. Not a battlefield, not a throne room,
not a place of drama or urgency or noise. We are going to a quiet room in ancient China where a man is sitting beside a clay furnace in the middle of the night, surrounded by jars of powdered minerals and dried herbs and careful handwritten notes. And he is trying to do something that human beings have been trying to do since the beginning of recorded time. He is trying to live forever. He will not succeed.
But in the process of failing, he and the men who came before and after him will accidentally discover something that will change the world more completely than almost any other invention in human history. Tonight, we tell the story of gunpowder. Not the gunpowder of cannon fire and warfare, not the gunpowder of drama and destruction. The quiet story, the slow story. The story of curious minds working in firelit rooms across centuries, following questions wherever they led, making mistakes that turned out to matter enormously, building knowledge one careful experiment at a time.
This is the story of how an ancient civilization, looking for the secret of immortality, found something completely different, and how that accident changed everything. Before we begin, drop a comment below telling me where in the world you are watching from and what time it is there. This channel reaches people in places I have never been, at hours I will never see, and every comment reminds me that we are all, in some fundamental way, part of the same story. Close your eyes, take one slow breath in, and let it go. Let us begin.
The body was to bring it into alignment with the deeper harmonies of the natural world, and to preserve the body indefinitely, to achieve immortality, was to achieve the ultimate alignment, to become, in some sense, like heaven itself, permanent and unchanging, beyond the reach of time. The Feng Shi pursued this goal with extraordinary dedication and creativity. They developed practices of breathing and movement, what we now call Qigong, designed to cultivate and circulate qi through the body in ways that would strengthen and preserve it.
They developed dietary practices, eating certain foods and avoiding others, based on their theoretical understanding of how different substances affected the body's internal balance. They developed meditation practices aimed at transforming the mind along with the body. And they developed medicine. The medical knowledge accumulated by the Feng Shi and their descendants is one of the great intellectual achievements of ancient China. Working from their theoretical framework of qi and yin and yang and the 5 phases, Chinese physicians developed an extraordinarily detailed and practically effective system of diagnosis and treatment.
They mapped the pathways of qi circulation through the body in what they called meridians. They discovered that inserting thin needles at specific points along these meridians could alter the flow of qi in ways that relieved pain and illness. Acupuncture, which is now practiced in hospitals and clinics across the world, is a direct descendant of this ancient practice. But alongside the legitimate medical knowledge, the Feng Shi were also pursuing the more ambitious goal of physical immortality. And this pursuit led them into territory that was far more dangerous.
The search for immortality in ancient China focused heavily on substances,
specific materials that, if properly prepared and consumed, might strengthen the body against decay and extend life indefinitely. The Fangxi were essentially pharmacologists, but pharmacologists working toward an extreme and unusual therapeutic goal. They tested everything: herbs and minerals, animal products, substances found in unlikely places. They were systematic in a way that modern researchers would recognize. They recorded what they used, what preparation they applied to it, what effects they observed. They compared notes with each other. They built up a literature of alchemical knowledge that grew over centuries, and gradually, through this process of testing and recording and comparing, certain substances emerged as particularly promising, substances that seemed to have special qualities, special powers. Gold was one of them. Gold did not rust. Gold did not decay. Gold endured while everything around it crumbled. To the Fangxi, this was not merely a physical property. It was a cosmological one. Gold had achieved, at the level of metal, something like what the immortal sought at the level of person: the preservation of form through time. The resistance of entropy. If you could find a way to introduce the quality of gold into the human body, perhaps the body would take on that quality. Perhaps it would become like gold, resistant to decay. The Fangxi experimented with gold extensively. They ate it in powdered form. They dissolved it in acidic liquids and drank the result. They developed elaborate procedures for transforming gold into forms they believed would be more easily absorbed by the body. Some of them died from these experiments. This was, in a grim sense, useful data. The search continued. The substance that would eventually lead to gunpowder came into the story gradually, over centuries, through a complicated web of alchemical inquiry that touched on minerals and their properties and the transformations they underwent when heated and mixed. One of the most important of these minerals was sulfur, would take on that quality. Perhaps it would become like gold, resistant to decay. The Fangxi experimented with gold extensively. They ate it in powdered form. They dissolved it in acidic liquids and drank the result. They developed elaborate procedures for transforming gold into forms they believed would be more easily absorbed by the body. Some of them died from these experiments. This was, in a grim sense, useful data. The search continued. The substance that would eventually lead to gunpowder came into the story gradually, over centuries, through a complicated web of alchemical inquiry that touched on minerals and their properties and the transformations they underwent when heated and mixed. One of the most important of these minerals was sulfur. Sulfur is a remarkable substance. It is one of the few elements that occurs in pure form in nature, found in yellow crystalline deposits near volcanic vents and hot springs. It burns with an intensely blue flame and produces a sharp, acrid smell that ancient peoples across many cultures associated with divine or supernatural forces. The Greeks called it the divine brimstone. The Bible uses it as a marker of divine destruction. The Chinese Fangxi were fascinated by sulfur for several reasons. It burned, and burning was transformation. When a substance burned, it underwent the most dramatic visible transformation available to the ancient chemist. It changed its nature entirely. Solid became gas. Form dissolved into formlessness. Something apparently inert became violently active. To the Fangxi, working within a framework that saw all natural change as potentially instructive, the dramatic transformations of combustion were full of significance. Sulfur also had medical applications. Applied externally, it could treat certain skin conditions. Ingested in small quantities, it seemed to have effects on the body, though these were not always the effects desired.
The Feng Shi added it to their pharmacopoeia and continued their experiments. The other critical ingredient in the eventual discovery of gunpowder was saltpeter, which the Chinese knew as fire salt or ground frost. Saltpeter is potassium nitrate, a white crystalline substance that forms naturally in certain soils, particularly in soils rich in organic matter that has decomposed in specific conditions. In ancient China, it could be found as a white crystalline crust on old walls, in caves, in the soil of stable floors where animal waste had accumulated and decomposed over years.
The Feng Shi noticed several things about saltpeter that made it interesting. It had a cooling taste, unlike the burning taste of sulfur. It dissolved easily in water. It affected the combustion of other substances in unusual ways. When added to a fire, it intensified the burning, making flames brighter and more energetic. There was something about saltpeter that fed fire. Within the theoretical framework of Chinese alchemy, this was significant. Fire was one of the 5 phases. The ability to influence fire was the ability to work with one of the fundamental forces of the cosmos.
A substance that intensified fire had power, and power was interesting. The Feng Shi added saltpeter to their investigations. And then there was charcoal. Charcoal is one of the oldest materials in human use. It is simply wood that has been heated in the absence of oxygen until it has been reduced to almost pure carbon. Every ancient culture had charcoal. It burned hotter and cleaner than wood. It was lighter and easier to transport. It was the fuel of metal workers and potters and smiths. The Feng Shi used charcoal in their furnaces as a matter of course.
It was not in itself a particularly interesting substance to them.
It was simply fuel. But these 3 substances, sulfur, saltpeter, and charcoal, were all present in the alchemical laboratories of ancient China. And they were all being used in various combinations and preparations by men who were conducting systematic experiments with heat and transformation. The question of exactly when and how someone first mixed all 3 together and discovered what happened is one that history cannot answer precisely. The discovery did not happen in a single moment of revelation. It happened gradually, through a process of accumulated experiments and shared knowledge, over a period that may have spanned several generations.
What the early alchemical texts record is not a triumphant announcement, but a warning. This is significant. The first written references to what we would recognize as gunpowder in Chinese alchemical texts are not descriptions of a new and useful discovery. They are cautionary notes. They are essentially records of accidents. One of the earliest references, from an alchemical text of the Tang Dynasty, probably dating to around the 9th century CE, describes the result of a particular alchemical experiment in terms that are unmistakable.
The text records that when sulfur and realgar, another sulfur-containing mineral, were combined with saltpeter and honey, which contains carbon, and heated, the result was a violent fire that burned the hands and faces of the alchemists and set fire to the building they were working in. This is not a description of a successful experiment. This is a description of a catastrophe, and the text that records it does so as a warning to other alchemists. Do not do this. This mixture is dangerous. This combination of substances produces uncontrolled fire.
The men who wrote this warning had discovered something remarkable. They had found a mixture that, when heated, produced a fire of extraordinary violence and speed. A fire that could not be controlled in the way that ordinary fire could be controlled. They did not immediately think about weapons. They thought about how to avoid burning down their laboratories. This is actually a remarkably human response to an accidental discovery. The first reaction to something unexpected and dangerous is not to wonder how it might be useful. It is to be frightened of it. To want to understand it well enough to avoid it, to warn others. But the alchemists were systematic people. They wrote down what had happened.
They described the conditions that produced the violent fire. They recorded the proportions of the substances involved. And in recording all of this, they created a body of knowledge that others could build on. The catastrophic experiment was not repeated carelessly, but it was not forgotten either.
In the quiet of their laboratories, by the light of their clay lamps, in the long hours of the night when the city outside was sleeping and the furnace was burning low, the
Fangxi continued their work. They were careful now with these particular substances. They approached them with the respect that dangerous things deserved. But they kept investigating. They had found something strange and powerful, and they were incapable of simply leaving it alone. This is the other thing that makes the story of gunpowder so human. Curiosity does not stop at the edge of the known. It does not look at something dangerous and unknown and decide it has seen enough. Curiosity pushes forward. Curiosity accepts discomfort and risk in exchange for understanding. The Fangxi were curious. And so the investigation continued. Let your breathing slow now. The night is quiet. The furnace is burning low. The next experiment is still hours away.
The Chinese alchemists worked in a world that was simultaneously intensely practical and deeply symbolic. Every experiment they conducted had two levels of meaning. The practical level, what physically happened when these substances were combined under these conditions, and the theoretical level, what this result meant within the cosmological framework of qi and yin and yang and the five phases. This dual nature of Chinese alchemical thinking actually helped the development of knowledge in some ways and hindered it in others. It helped because the theoretical framework gave the alchemists a reason to investigate systematically. Within the five phases theory, every substance had specific properties and affinities and transformations that connected it to the larger system. Understanding a substance meant understanding its place in that system. And understanding its place in the system meant investigating its behavior thoroughly. The framework demanded comprehensiveness. It hindered because the theoretical interpretations sometimes led investigations in directions that were, from a modern perspective, dead ends. The belief that gold could confer immortality if properly prepared and consumed was theoretically coherent within the alchemical framework, but practically false, and sometimes lethal. Mercury was considered a particularly powerful alchemical substance because of its unusual properties, the way it moved at room temperature as a liquid, the way it combined with other metals to form amalgams, the way it transformed so dramatically when heated. Mercury compounds were prepared and consumed by alchemists seeking immortality. Mercury is a severe neurotoxin. Several emperors who consumed mercury-based elixirs in pursuit of long life died early, possibly as a result. The alchemical framework was not science in the modern sense. It did not have the modern discipline of falsifiability, the requirement that a theory must be testable and must be abandoned if the tests fail. It was more flexible than that, more interpretive, able to accommodate anomalous results by adding complexity to the theory rather than revising its foundations. But it produced real knowledge anyway, because the alchemists were observing real substances, undergoing real transformations, and recording what they saw. Whatever theoretical framework they applied to their observations, the observations themselves were accurate. And accurate observations, accumulated over generations and shared through a tradition of written texts, eventually add up to real understanding, even when the theoretical interpretation is wrong. The development of gunpowder knowledge during the Tang Dynasty followed this pattern. The initial catastrophic discovery had established one thing clearly: a mixture of sulfur, a carbon source, and saltpeter in roughly the right proportions produced a violently rapid combustion when ignited. The fire it produced was not like ordinary fire.
It was almost instantaneous. It produced a burst of light and heat that happened too fast to control.
The alchemists who inherited this knowledge began, carefully and systematically, to investigate it. They varied the proportions. This was the most important methodological step. By changing the relative amounts of each ingredient and recording what happened, they could begin to map the behavior of the mixture across a range of compositions. More sulfur, less sulfur, more saltpeter, less saltpeter, different carbon sources. Honey, which the original text had mentioned, produced slightly different results than charcoal. The moisture content of the honey changed things. The particle size of the charcoal changed things. The work was slow. Each experiment had to be conducted carefully, at a safe distance from flammable materials, with attention to the quantities involved. The alchemists had learned from their predecessors' accidents. They treated the mixture with respect, but they persisted. And gradually, over decades and generations, the knowledge accumulated. They discovered that the proportions mattered enormously. A mixture with too much sulfur burned badly, incompletely, producing mostly smoke. A mixture with too little saltpeter burned sluggishly, without the characteristic explosive speed. There was a range of compositions, and within that range there was a sweet spot, a set of proportions that produced the most energetic reaction. They discovered that the form of the ingredients mattered. Coarser materials burned more slowly than finer ones. Grinding the ingredients to a fine powder before mixing them changed the behavior of the mixture dramatically. They discovered that moisture affected the mixture. Too wet, and it would not ignite properly. Too dry, and it ignited too easily, presenting handling dangers. All of this was knowledge. Practical, accurate, reproducible knowledge about how a specific set of materials behaved under specific conditions. It was knowledge obtained through systematic observation rather than through theoretical deduction. It was, in this sense, genuinely empirical, genuinely scientific in the most fundamental meaning of that word.
The Tang Dynasty, during which this knowledge was being accumulated, was in many ways the most cosmopolitan period in Chinese history. The capital at Chang'an, modern Xi'an, was one of the largest and most diverse cities in the world. Merchants and diplomats and monks and artists came to it from Central Asia and India and Persia and the Byzantine Empire. Ideas traveled along the Silk Road in both directions, carried in the minds of travelers alongside the silk and the spices and the gold. The alchemists of Tang Dynasty China were not working in isolation.
They were part of a broader intellectual culture that valued curiosity and investigation and the accumulation of useful knowledge. The same period that saw the development of gunpowder knowledge also saw major advances in Chinese medicine, in Chinese mathematics, in Chinese engineering. The culture of inquiry that produced gunpowder was not a special or unusual feature of Chinese civilization at this moment. It was the normal operating mode of a civilization that had been investing in systematic knowledge for centuries. And outside the laboratories of the alchemists, the world of Tang Dynasty China was going about its business in ways that would eventually intersect with the new discovery. The military was always looking for better weapons. The military had been looking for better weapons since before the Zhou dynasty. China's long history of warfare between states, followed by the constant threat of nomadic incursions from the north and west, meant that military innovation was never simply an academic exercise. It had immediate, life and death practical importance. The connection between the alchemical laboratories and the military workshops did not happen immediately. The Fangxi were not, primarily, weapons developers. They were seekers of immortality who had accidentally found something dangerous.
The thought of turning that danger into a weapon was not their first thought, or their second thought, but the thought came eventually. Because in a civilization of curious, systematic, practically minded people, a substance that produced violent fire on demand
was not going to remain in the laboratory forever. The night is very quiet. The furnace has burned down to coals. The alchemist makes a note in his book and closes it. Tomorrow, the next experiment.
The transition from laboratory curiosity to military technology happened gradually through a series of small steps, each one building on the last. The first military applications of gunpowder were incendiary. They were about fire, not explosion. The Tang military engineers who first experimented with the new substance were not trying to propel projectiles or create blasts. They were trying to make better fire weapons. Fire had always been a weapon of war. Fire arrows, pots of burning oil, incendiary materials thrown from walls at attacking forces.
Fire was terrifying, difficult to extinguish, psychologically devastating to troops and to the horses that were so important in ancient Chinese warfare. A substance that burned more intensely than anything previously available, that ignited almost instantly, that produced a burst of light and heat that was shocking in its suddenness, was obviously useful in this context. The early gunpowder weapons were fire arrows, simple devices, an arrow with a small packet of the powder mixture attached to its shaft, ignited before release. The arrow flew with its fire attached, carrying the burning mixture to its target. The effect on a wooden fortification, or a thatched roof, or a sail was devastating. But even as these simple applications were being developed, the military engineers were observing something else about the new substance, something that would eventually lead to a completely different kind of weapon. The powder did not merely burn, it produced gas. When the powder burned, the chemical reaction that produced the light and heat also produced a large volume of gas almost instantaneously. The sudden expansion of this gas was what gave the burning such violence. The gas expanded so rapidly that it pushed outward with tremendous force in all directions. In an open space, this force simply dissipated into the air, producing the flash and smoke and noise that had characterized the alchemists' accidents from the beginning. But in a confined space, something different happened. This was the crucial insight. The insight that transformed gunpowder from an incendiary into something altogether more powerful.
If the powder was burned in a container that was strong enough to withstand the initial pressure of the expanding gas, but had one end open or weakened, the gas would push out through that opening with enormous force. And if something were placed in the path of that gas, the gas would push it. The physics of this is simple, and the same physics that underlies every gun and cannon ever built. A controlled, directed explosion in a confined space produces a directed force. The first devices that used this principle were bombs. Hollow containers, typically of bamboo or ceramic, packed with the powder mixture and sealed. When the powder was ignited, the container could not contain the expanding gas, and it burst violently, sending fragments of the container and the burning powder outward in all directions. The blast of the explosion itself had force. The noise of it was shocking and disorienting. These firebombs, as they were essentially called in the military texts of the Tang period, were significant weapons. They could be thrown by hand or launched by catapult. They were particularly effective against troops in tight formations. The combination of fire, noise, concussive force, and flying fragments made them genuinely terrifying. The noise deserves special mention. The sound of a gunpowder explosion is a weapon in itself. In a world where warfare was conducted by human beings and horses, all of whom had evolved nervous systems designed to respond to sudden loud sounds with panic, the ability to produce a noise of extraordinary volume and suddenness was tactically valuable beyond the physical damage caused. Horses bolted, troops scattered, formations broke. The psychological weapon was as important as the physical one. The military engineers noted this and began developing devices designed primarily for their noise and flash rather than for their physical effects. These were essentially the first firecrackers.
And here we encounter one of those moments where military and civilian history intersect in an unexpected way. Because firecrackers, which became an integral part of Chinese festival culture, did not originate as entertainments. They originated as weapons. The same properties that made them useful for disrupting enemy troops also made them useful for other applications where sudden noise and light were desired. Chinese tradition held that loud noises frightened away evil spirits.
Firecrackers were therefore used at New Year celebrations and weddings and other significant occasions to purify the space, to drive away malevolent forces, to create an atmosphere of protective noise and light. The military technology was seamlessly adopted into civilian religious and cultural practice. This crossover between military and civilian use would continue throughout the history of gunpowder technology. The same substance that was being refined for military purposes was also being developed for entertainment. The elaborate fireworks displays that Chinese culture became famous for grew from the same technical tradition as the firebombs and fire arrows.
There is something characteristic about this. Chinese culture has always been good at finding the beauty in things that also have dangerous applications. The same technical knowledge that could burn down a building could also create a chrysanthemum of colored light in a night sky. The Tang Dynasty, which began in 960 CE, saw the most rapid development of gunpowder technology in the pre-modern period. The Tang Dynasty faced a severe and persistent military challenge. To its north, a succession of powerful nomadic states, the Khitan Liao dynasty, the Jurchen Jin dynasty, and eventually the Mongols, posed a constant existential threat. The Song military needed every advantage it could find. Gunpowder gave them several. Song military engineers developed the fire lance, which was the direct ancestor of the gun. The fire lance was essentially a tube, initially of bamboo, packed with powder and projectiles that was used as a close-range weapon. When ignited, it shot burning powder and debris outward from its open end with significant force. A soldier holding a fire lance could project a burst of fire and shrapnel at close range. The fire lance was not yet a gun in the modern sense. It was not precise enough to aim at a specific target. The tube could only be used once, or a small number of times, before it wore out. And the projectiles it fired were irregular fragments, rather than shaped projectiles designed for accuracy. But it was the prototype. From the fire lance, the development of the gun was a series of engineering refinements, rather than a conceptual leap. Stronger materials, first reinforced bamboo, then iron and bronze, to contain the force of the explosion and allow for multiple uses. More precisely shaped projectiles, spherical iron balls that could be aimed more reliably. Better powder formulations that produced more consistent results.
By the end of the Song dynasty, Chinese military forces were using devices that a modern observer would recognize as primitive guns and cannons. The knowledge of these weapons and samples of the powder itself traveled westward along the Silk Road and through the networks of the Mongol Empire, which connected China to the Islamic world and eventually to Europe. In Europe, gunpowder arrived in the 13th century, and the first European cannons appeared in the early 14th century. By that time, China had been using gunpowder weapons for several centuries.
The fire lance rests in the corner of the workshop. Tomorrow, the engineers will refine the proportions again.
Let us step back from the workshops and the weapons and the military campaigns and return to the quiet room where the story began. Because the story of gunpowder is not, at its heart, a story about weapons or warfare. It is a story about curiosity. It is a story about what happens when human beings pay close, systematic, patient attention to the world around them and record what they find and share that knowledge with others who build on it.
It is a story about the accumulation of knowledge across generations, the slow construction of understanding through countless individual acts of observation and experiment and record-keeping. The Fangxi who first combined sulfur and saltpeter and charcoal in their clay furnaces were not trying to invent a weapon. They were trying to understand the natural world. They were trying, within the framework of their time and culture, to answer the deepest questions human beings ask. Questions about life and death and transformation and the possibility of transcendence.
They failed, in the sense that they did not find the immortality they were seeking. But in failing, they found something else. And this is actually the pattern of much of the most important discovery in human history. The thing that was found was not the thing that was sought. The path led somewhere unexpected. The mistake turned out to matter. This is worth thinking about for a moment. The history of human knowledge is full of accidental discoveries.
Substances and phenomena and principles that were found not because someone was looking for them specifically, but because someone was looking carefully at the world and noticed something unexpected and paid attention to it rather than ignoring it. The Fangxi who first noticed that a mixture of sulfur and saltpeter and carbon caught fire with unusual violence did not throw away the ruined experiment and consider it a failure. They recorded what had happened. They tried to understand it. They included it in the body of knowledge that they passed on to their students and successors.
This instinct to preserve even the failures, to regard even the accidents as data worth recording, is what made the eventual development of gunpowder possible. If the first alchemist who accidentally created the mixture had simply noted it as a dangerous mistake to be avoided and moved on, the knowledge might have died with him. But it was recorded, and because it was recorded, it could be built on. Chinese civilization had, by the Tang Dynasty, developed an extraordinary infrastructure for the accumulation and transmission of knowledge.
The invention of paper and printing, which happened in China centuries before it happened anywhere else, meant that knowledge could be recorded cheaply and shared widely and preserved across time. The examination system, which required that educated men study the great texts of Chinese intellectual tradition, meant that there was a large class of literate people capable of producing and consuming written knowledge. The alchemical tradition itself had a long history of written communication. The Fangxi wrote their observations down. They compiled reference texts. They created what we would now call scientific literature, accounts of experiments performed and results obtained and conclusions drawn. This literature was not perfect. It mixed accurate observation with theoretical speculation in ways that are sometimes hard to disentangle. But it existed. It accumulated. It was shared. And the knowledge of gunpowder accumulated within this tradition, growing from the initial cautionary warnings of the first accidental discovery through the systematic investigations of generations of alchemists to the military applications of the Tang and Song military engineers. The full development from accident to weapon took roughly 4 centuries. 4 centuries of careful observation. 4 centuries of recorded experiments. 4 centuries of knowledge being passed from teacher to student, from alchemist to alchemist, from text to text. This is the timescale on which real understanding is built.
Not in the flash of a single inspired moment, but in the slow accretion of observed fact after observed fact, the patient construction of a building that no single person could have built alone, that required the contributions of people who never met each other, who were separated by generations, who shared only the habit of paying attention and writing down what they found. Consider what those 4 centuries looked like from inside them. No individual alchemist working in the early Tang Dynasty
knew that they were contributing to the development of a technology that would eventually change the entire course of human warfare. They were simply working on the problems immediately in front of them. They were curious about a strange and dangerous substance. They wanted to understand it better. They made their observations and wrote them down. No individual military engineer in the late Tang or early Song dynasty knew that the devices they were developing would eventually spread across the world and transform civilizations they had never heard of. They were solving specific military problems. They needed better weapons. The new powder gave them possibilities they had not had before. They explored those possibilities systematically and practically. The significance of what they were doing was invisible to them because it existed in a dimension of time they could not see: the future. This is one of the most interesting things about the history of invention and discovery. The people who make the discoveries almost never understand what they have found.
Not because they are unintelligent, but because the meaning of a discovery depends on what comes after it, on what other people do with it, on how it connects with other discoveries and other technologies and other social conditions. The meaning of gunpowder was not in the powder itself.
It was in the long chain of consequences that the powder's discovery set in motion. Consequences that unfolded over centuries and across continents, and that are, in some sense, still unfolding today. Because the world shaped by gunpowder is the world we live in. The nation-states of the modern world were shaped by gunpowder. The heavy cavalry of the medieval period, armored knights on armored horses, represented a form of concentrated military power that gave rise to a particular kind of social structure, the feudal system, built around the production and maintenance of that cavalry. When gunpowder weapons made heavy cavalry obsolete, the social structures built around it became obsolete too. The age of knights gave way to the age of infantry armies, and infantry armies required the organizational and financial resources of the centralized state. The nation-states of modern Europe were, in part, a response to the demands of gunpowder warfare. The age of oceanic exploration was shaped by gunpowder. The ships that carried European explorers to the Americas and around Africa to Asia were armed with cannons. The military advantage that gunpowder weapons gave to Europeans in their encounters with peoples who did not yet have them was one of the decisive factors in the extraordinary expansion of European power during the 16th and 17th centuries. The empires that built the modern world, the Spanish Empire, the British Empire, the Portuguese Empire, were built in part on the military technology that originated in the experiments of Chinese alchemists looking for immortality. And the Americas that were colonized, and the Africa that was enslaved to supply labor to those colonies, and the Asia that was eventually dominated by European powers. All of this was downstream from a discovery made in a Tang Dynasty laboratory in the 9th century CE. This is not to say that Chinese alchemists were responsible for the history of European colonialism. The chain of causation is far too complex for that kind of simple attribution. Many other factors, economic and cultural and geographic and political, contributed to the world we live in. History is never the product of a single cause, but gunpowder was one of the threads woven into the fabric of the modern world, and that thread began in ancient China. There is something deeply strange and wonderful about tracing the path from that quiet laboratory where a man was heating minerals in a clay furnace, trying to live forever, to the world we inhabit today. The path winds through centuries and continents. It passes through military workshops and festival grounds and ships' arsenals and European battlefields. It connects people who never knew of each other's existence, who lived in different worlds, who would have been incomprehensible to each other if they had somehow met. And yet they are all part of the same story. The story that began with a question about mortality and ended with the invention of a technology that changed how human beings kill each other
and explore the world and celebrate their festivals. The story that began in failure and ended in transformation. The story of the accidental fire. Let your breathing slow now. The laboratory is quiet. The furnace has cooled. The notes are written in the book.
The alchemist closes the book and sets it on the shelf beside all the other books. The accumulated knowledge of generations, the slow, careful construction of understanding, page by page and experiment by experiment and century by century. Outside, the Tang Dynasty city is going about its business. Merchants in the markets, monks in the temples, children in the streets. The enormous, ordinary life of a great civilization, most of which has nothing to do with alchemy or weapons or the slow revolution that is being quietly worked out in this back room. The furnace cools. The night deepens.
Somewhere in the city, a bell strikes the hour. The alchemist sits for a moment in the silence. He did not find immortality today. He never will. But he found something. He is not yet sure what it means. He closes his eyes. The notes are written. The work continues tomorrow. Your breathing has slowed. Your hands are heavy. Your body is sinking gently into the surface beneath you. The story of the accidental fire is still unfolding. It has been unfolding for 12 centuries. It will go on unfolding long after tonight.
But tonight, it has told you what it knows. And now it is time for you to sleep. The furnace is cold. The laboratory is dark. The ancient city breathes slowly in the night. The stars above it are the same stars that shone above every alchemist who ever worked by lamplight in search of something they could not quite name. They are still there, still watching, still patient. Let the night hold you now. Let the breathing of the old city slow your own breath.
Let the darkness behind your eyes become the darkness of a Tang Dynasty night, deep and warm and full of the quiet promise of a world that is still in the process of becoming itself. You are safe. You are warm. The story has been told. Now sleep. Slowly, gently, like the fire in the furnace, burning down to embers, to warmth, to dark. Good night.